Well, we're back in the shop here again with Greg, Street Muscle Magazine. We're getting ready to start kind of get into the meat and potatoes of some of the build. And one of the things we're kind of looking at, again, you can see kind of the behind the scenes, what goes into this is exhaust. Greg, you needed to build an exhaust on this car. I would have thought you went with stainless steel, but you decided to go with titanium, which I kind of caught me off guard at first. You know, why did you decide to go with titanium?
Well, you know, I actually had the stainless material here in the shop for a while, and I was getting ready to start that. And you know, the thing is, when you go to the PRI show, sometimes you get some great ideas. And every year there are cars there that are just unbelievable. And being a fabricator, I just thought, hey, the stainless is perfectly adequate for this application, but it takes a lot of time, even just to make a 15-inch long exhaust pipe coming off a turbo through the engine bay and out the fender. So the time that it takes to do that, I thought, why not just make it out of titanium? Just because you're not saving a little bit of weight, but it's just kind of a cool factor, and you know, it just adds another element of custom to a custom build. So essentially,
plus you get to learn a new skill because you never really welded on titanium, have you?
Exactly. I tried it once a long time ago, but that was never put into use. So I just thought I need to see what that's like. But as far as a project or an actually finished product, no. So this will be something new. This company, TiCON, has actually a little sample pack that's very reasonably priced. And I was not aware of this, but I was talking to the salesman, and you can buy just some odd pieces and some filler rod just to practice. So obviously you don't want to start practicing with the real thing.
Yeah.
And have a bunch of this stuff laying in the scrap pile, because that's not a good idea. So this will at least be a starting point to kind of get the heat figured out. One thing that's important with Ti, it's very thin, so you have to turn the heat down on the welder, and controlling the arc is very critical. Something they also sell is this trailing shield. So the titanium is very critical. It has to have a lot of argon coverage. You also have to back perch the inside of the tubing when you're welding it. So anytime that is molten or still in a state where it's very hot, it has to be covered with argon. Otherwise, you'll have problems and it'll fail and crack. So this is a nice tool. I've never used one of these either. So this will be a little practice session here before we get into the real thing of making the real parts.
And again, that's the kind of thing that people don't understand, that it's not just, hey, you're going to whip this together. You got to learn new skills when you're doing something like this. And using the titanium is going to have its own benefits, more skills if you want to start to use titanium later. And then it was kind of a challenge to find the right stuff. So that's why you kind of have this, we'll call it a grab bag mixture stuff here. So let's kind of go right to left, some of the stuff that you have to, let's talk about the parts that you're going to use to build this exhaust.
Yeah, so I bought the turbos a while back, and it has a 4.5-inch outlet, which it's not a real common size. The 4 and the 5-inch are more common. But the V-band flanges were not available, and I looked and looked, and none of the vendors and suppliers and parts manufacturers had a 4.5-inch outlet coming off the turbine housing. So I reached out to a friend and made contact with a guy in Chicago. He has a machine shop. He's also a racer and does very high-end work. And I sent him one of the stainless flanges. He looked at it and said, "Hey, I can take care of this for you and make these." So I said, well, let me drive out there. I want to bring a camera and just kind of talk to you about your machine and how this works, and get some footage on actually carving out a block of titanium into a V-band flange in 4.5. So we have some footage of that, which will be pretty interesting to show. So this is 4.5 OD here, 4.5-inch titanium V-band flange, and then also all the other parts. These are called pie cuts. They're basically small little radius pieces, and you basically have to get in there and figure this out on your own, and to get from A to B. This is a 45, and coming out of the turbo, since they're not symmetric, each tube is different, and it's a matter of just kind of working through it.
So we'll kind of jump here real quick and show people the footage from Chicago where you got to talk to the gentleman. He explained it. So we'll morph and go to Chicago for a moment.
Yeah, so what do we got going on here?
A little bit of titanium today. Some sort of don't know, some old Camaro or something. I don't know. This is what we started with. Some chunks of titanium, and this is what we're gonna turn it into.
And the machine here, what are we looking at?
This is an Akuma. It's a 2010 Akuma. So it's been a good machine. Ignore the window. Get that out of here.
All right.
Yeah.
And Mastercam is a software?
Yeah. We're
Right.
programming everything on here with Mastercam. So.
Awesome. All right.
So slow with it. Your speeds and feeds are generally pretty slow. So there's some things you can do to speed stuff up, but on the whole, like you're still cutting relatively slow. So yeah, we'll get this going.
Now, why is that? Just the nature of the material itself?
Yeah, it's like the hardness. It is considered like a heat-resistant super alloy, so you can work harden material like that. Specifically like stainlesses, you can work hard, and you've got to go relatively slow with stainlesses too, but it's the hardness of the material. So generally, from a machining standpoint, everything that we're doing is SFM, right? So you're either at a high surface footage or you're at a low surface footage. It's like kind of the surface speed that the material is being cut at, basically. So you're spinning it fast or you're spinning it slow. If you spin it slow, it's going to slow everything down. So your feed rates are kind of proportional to your surface footage, basically. So
Gotcha.
yeah.
Okay. So that is a raw piece of
Yeah, 6AL 4V titanium. It's a 5-inch diameter, about just a little over an inch thick, and it'll be, it's almost nothing left when you're done with it. So,
right.
yeah.
Who gets to keep the leftovers?
You're welcome. I will bag these chips up, and you can take them home if you want.
Right.
So.
Awesome.
Yeah.
Now, I've heard the material, when you machine it, cut it, it can be reactive. So, at what point is it dangerous?
I wouldn't say it's like it's dangerous if you cut it improperly. If you, it might be kind of akin to tuning a car in methanol. Like everything's okay until it's not. You just have like a narrow, and I know with methanol you have like a wider window of for tuning your fuel. But with something like this, you've got kind of like a narrower window, of where you can be cutting at and be okay. Whereas with something like aluminum, you could be Helen Keller and get this done with just about anything. You'd have to be real special to screw it up, basically. So.
Gotcha. Okay.
Yeah. So,
Gotcha.
without further ado, we can get this thing started.
Okay. What's the orange finish on there? Is that just a protected
paint, basically, so that the manufacturer can figure out like what the material is.
It's like a quick ID, just color coded maybe in the mill.
Spray paint or something.
Do that with lumber, same thing. Yeah.
So this is basically 1.1" insert drill.
Wow.
And we're just gonna dig a little pilot hole through the center, basically, so that we can go in with our rough pouring bar and remove the bulk of the material, basically.
So is that bit going to get used up a lot faster cutting this material, or not really?
Yes and no. I mean, I don't have like insert specific for titanium here. There's really not too hard. So being a little bit freezer about how we're cutting it. So
you just alter your rate and your feed speed, just kind of how you attack it, so to speak.
yeah. The big thing is surface footage, basically. So yeah, you can see there basically like a minute, 1 minute, 12 seconds with the pilot hole in there. So.
Got it.
Yeah. So now, this next portion, we're going to run our rough boring bar. bore out the center of the part. And this is going to rip for a little while, so
Okay.
like I say, if you want kind of thing right in here,
Yeah. How long will that one take, you think?
half hour.
Oh, really? Okay. All right. Maybe I'll come back and think of any efficiencies,
That's correct, yeah.
so to speak.
The machine's dumb, basically. So if the machine does something dumb, it's because I'm dumb. It's really my job to design like a manufacturing process to produce this correctly. So you can get yourself into trouble. Like when I first started programming this, I actually started programming it from the other side first, and I was like, maybe it would make more sense to do it the other way and start with this side first. So I kind of flipped around and changed my strategy a little bit, and that's the kind of stuff like that you've got to think of as I guess manufacturing engineer.
Right.
You're thinking of that stuff kind of on your feet. So generally if we get an order from a customer, it's like a new order. They give us a drawing or a CAD file or something, and they give us an order. We then have 4 to 6 weeks to design that process, order tooling, schedule it in our machines, set it up in our machines, program it, cut it, and then QC the part, pack and ship it. So it's a lot of shit basically. So something like this is pretty simple. It's a pretty easy little part, but obviously not all of that stuff's like that. So.
Right. Gotcha. Okay.
And bam, we're back from Chicago. You got to see the stuff made. We've got all this stuff, Greg, and I think we've done a pretty good job explaining what people are, the what we're going to use. So next episode, on the next video, we're actually going to have Greg taking, footage of himself building the bullhorns, the modifying of the car, because once again, these the old Firebird didn't come with bullhorns from Mother GM, so you got to do a little bit of engineering to make that work, right?
Right. Yeah. Exactly.
Yeah. So you get to see Greg cry a little as he cuts holes in his perfectly good fenders. So you get to see that process, see it all done up, and we're all going to learn something, aren't we?
I think so. Yeah. Looking forward to it.
So there you go, folks. Make sure you stay tuned next time when we build an exhaust and cut up a perfectly good Firebird.